Hello everyone, and welcome to the latest of the Blatchford Prosthetic Product Showcase webinars. I'm just going to give it the last 30 seconds or so to start. We've still got some people joining in the last minute, and then I'll start today's presentation. Thank you. All right, okay. Hello everyone. Before we begin, I'd like to point out that all participations are on mute for a better experience so you can all hear. This webinar is being recorded, and like our previous webinars, will be made available on the web at some point. So should you need to refer to it at any point, you can get back to it. Please use the question panel on the right-hand side to ask questions as we go along. Bruce is online and he's ready to help out answering those questions. Handouts are available on the panel on the right as well. Webinar feedback survey will be distributed at the end of the webinar. Please complete this, especially for those of you who require a certificate of attendance, either for your continued professional development or for your employers. Register for future webinars at blatchford.co.uk webinars. I should say we're at least having a holiday for a couple of weeks, but we will load more up at some point. If you have any questions after this webinar or about anything else we've covered in the past, please feel free to contact me at john.ross@blatchford.co.uk and I will try and help you wherever possible. So today's webinar is Blatchford's Mercury hydraulic knee. I will be a presenter. My name is John Ross. I have been a prosthetist for over 27 years. I currently live and practice prosthetics here in southeast London. I have a keen interest in the holistic approach to treating transfemoral amputees. So I spend a lot of time using these type of knees that we'll be talking about. One of my main interests is in socket technology, so how we actually fit the socket to the patient so we can play about with these type of components that this knee falls into. As usual, we have an agenda I will follow through. Product overview, give you a bit of the background to it, the detail of the unit, the fitting recommendations, so that you have an idea of what you have to go through to fit this. I'm also including this some, if you want, tricks, cheats that we use when using this kind of thing. We have some common questions that have been asked, and some of you actually already sent in some questions you would like answered during the session, and then I'll have a summary session at the end. So first of all, how do we decide the best knee for our amputees? I'd like to start off by saying at the ISPO International in Japan last year, there were more than 500 knees in show. Okay. The best knee depends on many things: the patient, their health, the environment that patient lives in or works in, what support or stability they need, and the function requirements required to fulfill their ambitions and expectations. So this may be how they complete their activities of daily living and what their activities of daily living is. Do they go out to work? Or are they keenly involved in sports? Are they having to run after children? Do they have young children they need to look after? All these type of things will influence which knee is best for our patient. And we see this balance between stability and function. We can supply very stable legs that will in effect hold the patient up, but you can lose some functional aspects from this. Whereas sometimes to allow certain functions to perform and work at their maximum, you have to be able to decrease the stability you have for the patient. And so when we're choosing what is the best knee, much is down to clinical beliefs, experiences and understanding. Hence, there is no best knee. And that's why I started off with the fact that the ISPO in Japan, there was over 500 knees on show. All we can hope to get is the best knee that suits the individual who's in front of us at that point in time. What is the best knee for the patient as they present to us in clinic and as we are dealing with at the time? Typically, we know the lower mobility activity of the amputee, the greater the stability requirements. Well, coupled with our lower activity, we usually see lower functional levels. An example being a housebound transfemoral amputee walking with the aid of a frame is unlikely to need to run routinely. So removing that function will allow us to concentrate on the functions required and that are desirable to the amputee. Today I will be talking about hydraulic knees, primarily a single axis hydraulic knee aimed at the K3 and K4 amputees. For myself, I view the K3 amputee as someone who will do everything that an able-bodied person of a similar age and background would do. Now that may be dancing in a culture, going to the pub, or occasional sports, but not necessarily. Those of you who know me, I know I'm not an amputee, but I don't regularly partake in sports. But I would be comparing an amputee of a similar age from the west coast of Scotland, comparing them to me. Can they do everything that I would be expecting to do? And if the answer was yes, I would expect them to be treated as though they were a K3 amputee. It should also be noted the K3 amputee by definition has the ability to change walking speeds. Okay, but so this ability to change walking speeds or cadence is actually an integral part of how we determine someone's a K3 amputee. Okay, but also as we know, as clinicians, as users, and people involved in the field, that our preferred walking speed is that which is most energy efficient for us, and that speed at which we spend most of our time walking. So I said we're going to talk about the Mercury knee today. What is it? The Mercury knee is a robust hydraulic knee for the active lifestyle. It uses roller bearings to minimize maintenance. Roller bearings are the same bearings you would normally have, for example, in a car door. Okay, they're long lasting, they're robust, they take heavy loads, and they require no maintenance. Okay, so this makes the use of roller bearings in the Mercury knee, it makes it ideal for active users, especially those who are remote for the clinic or office. So if you have a patient who lives a long way from your office and isn't going to be able to come in at regular intervals for servicing and maintenance, then it becomes more desirable to have a unit that minimizes the maintenance requirements at that limb. I spend much of my life in Asia Pacific, especially in China and Korea and places like this. And one of the advantages of the Mercury knee is it's a slim mechanical knee. Okay, it allows variable cadence for a limited range of walking speed, so the patient can walk slower and faster when they're in large crowds. It allows leg over leg descent of stairs, especially in countries where people live in flats, apartments, and they have to go up and down steps for it. The ability to walk down steps naturally instead of one leg at a time means that they can keep up with their peers and are not being pushed down. Additionally, the unit has two user modes. This is you would commonly be found in the most advanced microprocessed knees, and it allows the user to swap between these user modes very easily. One of the other advantages is that not all countries will actually routinely supply a leg without cosmesis. So the photograph we see here, the soldier, he doesn't have anything covering his leg. That is still not common in many of the countries we live and work in, and many patients still prefer to cover their leg with some sort of cosmesis to make it at least leg shape, so that when trousers are on it, it's not so noticeable. The benefits to the user: normal walking. The unit will support you and keep up with their preferred walking speed. We set it to the patient's preferred walking speed, but it always allows variable cadence. The hydraulic cylinder inside the Mercury knee allows the user to change speed without having to concentrate on their prosthesis. Okay, this is one of the things that we find makes amputees more tired, is the fact that the more time they spend concentrating on their prosthesis, the less time they have to concentrate on the world around them. It's a yielding knee, so it yields into flexion for sitting, so you can sit down while having your weight spread evenly between two legs. This will reduce the amount of damage you cause to your sound limb. Okay, you're going to reduce degenerative joint disease in your sound limb. This is also an advantage for a young mother. So someone's carrying a baby, they can sit down and support the weight of the baby on both legs, as opposed to on many other legs. They have to take the weight completely off the prosthesis and lower themselves while supported on one leg. This is difficult enough to do at the best of times, but imagine carrying a load. I've already mentioned the ability to reciprocate down steps leg over leg, and also to use the yielding function to allow you to come down steep ramps and slopes easier. The unit has two user modes: cycling, it's pretty much self-explanatory, but I'll speak about later on again how to access it, and the fixed lock, which prevents flexion. This is great for the gym, any batting sports, and as I'll mention later on, it started off as being a design for American baseball and is also commonly used for golf. The hydraulic control most commonly used in the Mercury knee is that of the swing and stance type knee. As I said, it gives you variable cadence with independent adjustable flexion and extension resistance, so you can set it for the patient's preferred walking speed. And as we know, as clinicians, scientists, and users, everyone wants to spend most of their time walking at their preferred walking speed, as this is the most energy efficient walking speed for them to do, and no one wants to get tired unduly. It has an adjustable yield for sitting and stair descent, which can be chosen to control the rate that the knee bends when you want to sit down or when you want to come down stairs, leg over leg, so that you can actually control the speed of the amputee. This again has to be fine-tuned, because unfortunately no two amputees want to come down steps at the same speed or sit down at the same speed, so you have to be able to fine-tune it depending on the speed that is comfortable for the amputee, their height, their weight, etc., and those two user modes. First of all, China. So we have an amputee walking uneven terrain down a ramp. The ground is not even. He's going downhill. He needs to be able to walk comfortably and come down that and rely on the leg. But the exact same leg can be used for cycling. Okay, and this is the advantage of the user modes. It gives some of the functions that we're more commonly associating with microprocessor knee control in a slim mechanical hydraulic knee with low maintenance and no need for power. Moving on to the background, the technology. I already spoke about stance and swing, cylinder that is most commonly used in this. The hydraulic cylinder most commonly used is the S&S, or stance and swing control. This is used to maximize the patient's mobility. The stance and swing hydraulic cylinder controlling the knee is commonly described by the generic term S&S. So that's why I've called this slide the S&S history. Okay. The term is used around the world to design a cylinder pioneered by German engineers Hans Mauch and Ulrich Henschke. This was developed with the support of the American Veterans Administration studies conducted over several years in the late 1950s and early 1960s. And in 1968, the modern hydraulic Hensch-Mauch or Mauch S&S knee was developed. And the latest variation of the cylinder is used in our Mercury knee. These cylinders are now manufactured by several companies due to an open patent situation if made inside the USA. Two of them are most commonly prescribed around the world: the Blatchford, formerly Endlight K-Tech, which comes with a 3-year warranty, and the Malk, now owned by Osser, which comes with a 2-year warranty. This type of knee is intended for the K3, K4 user. It's meant for active walkers, as the initial design was aimed at military veterans. So for those people who are doing sports, hiking, camping, who are going to be away from power sources and need a low maintenance, rugged limb for outdoor work and leisure pursuits. The unit has a weight limit for K3 amputees of 150 kilograms and 145 kilograms for the K4. The unit is suitable for outdoor use as it is weatherproof, and we've had people using this during monsoon seasons and torrential downpours with no problems. It's important to pick out contraindications for this type of knee. As I said before, as we're increasing the function of this knee, we have lowered the stability on it slightly to allow the patient to maximize the benefits of the greater functional levels. So contraindication for this would commonly be the residual muscular weakness or proprioception dysfunction. Okay. Contralateral joint instability or pathology, especially affecting the knee or hip of the sound limb. Complicated conditions involving multiple disabilities would also need to be assessed by the clinician to make sure that the stability level achieved by this knee is going to be sufficient enough for your patient. And again, many of the functional benefits of this knee are not suitable to that K1 user who does not walk outdoors and who constantly uses a Zimmer frame or a similar walking aid while walking. So here we see transfemoral patient using the leg to walk down steps, leg over leg, half the foot off the stair. We adjust the yield to control the rate it comes down to suit that individual, and it means that they can walk down at a rate that is suitable for them or slightly slower, depending on how they push down through the limb. Then as they get down to the bottom, they can walk off. Everything's in normal function. They don't have to worry about tricking it or switching the stance mode for stairs on or off. The shin in the Mercury knee is actually the strongest we've ever made using a carbon fiber technology, and was designed specifically to minimize the maintenance, retaining the roller bearings throughout for strength. And then to further strengthen it, we included the stainless steel inserts distally. So this is the reason why we managed to get this carbon fiber shin suitable for 150 kilogram users and also up to 145 kilograms for the K4 user who is routinely involved in high impact, high stress sports. Moving into the product information. The Mercury knee actually has two types of hydraulic cylinder that can currently be fitted to it. The S&S, the stance and swing, which makes up 98% of the sales of the unit, and the swing only pictured on the right. The main difference is that the swing only unit is constantly in cycling mode. There is no stance control supplied by the cylinder. As I said, the S&S are the one most commonly used and is easily identified by the stirrup. So in the left-hand side picture, you can see the small catch, okay, or a wire latch that's on the back of the piston rod. This is called the stirrup, okay, and this is what allows you to transfer from normal function through to the different functions. I've already mentioned that the S&S, stance and swing, provides additional functions for the patient. The stance phase, this S&S stability includes a stumble recovery assistance for the patient. The yielding resistance allows leg over leg descent of slopes and stairs, and also the swing phase control to aid a natural gait pattern for the amputee. The unit uses two resistances. Okay, it is important to understand these S&S cylinders use a high hydraulic resistance for stand stability and a low hydraulic resistance for swing control. If high resistance is not switched off, it is difficult to get the knee to bend during swing, and this can trip the patient because the knee will not flex to allow adequate toe clearance as they swing the leg through. These cylinders are designed to switch automatically when the knee is hyperextended. So the unit will switch from the high stance resistance to the low swing resistance as you have a hyperextension moment at the knee, which will take place just before toe off. This allows for a natural pre-swing to take place. The first thing to do is to customize the yield or stance adjustment. What we do is we adjust the yield resistance to allow even weight bearing between both limbs during sitting. Using a 2mm Allen key, and we adjust the stance resistance for the patient, or the yield resistance. 12 o'clock is maximum resistance. And then you move to an anti-clockwise direction to 6 o'clock to minimize resistance. It's important to note that the stance resistance yield should never be reduced to below the 6 o'clock position. Too high a yield and the wearer will be slowed excessively as they sit down. This will push them backwards into the rear of the chair as the patient sits down because the knee doesn't allow them to sit in a controlled fashion. Alternatively, too low a yield and the wearer will rely on their sound limb excessively. And this we can commonly see because as the patient lowers themselves to the chair, you will notice their body align itself more by shifting over the sound limb so that they can sit down easier. So you see them moving away from the artificial limb if you have the yield resistance set too low. It should also be noted when the patient stands, don't ask them to pull back against the rear of the socket sharply before sitting down, because if you hyperextend the knee, stance will disengage. Okay, so they won't have that aid in sitting down. It's also important that you understand how the knee is working. At heel strike, the weight line passes behind the knee. This would typically tend to cause the knee to buckle. However, in the Mercury knee, the high hydraulic resistance from the cylinder prevents this. At this point, the hydraulic stance is on, and we have that high resistance. Looking actually inside the knee, what happens? The weight line passes behind the knee. This tends to cause the knee to buckle as you push down through the piston rod. At this point, the high hydraulic resistance from the cylinder prevents this by giving a resistance to the knee flexing. Hydraulic stance is on and prevents this knee from buckling. And at this point, when I explain to our undergraduates, I get them to think of a cafetiere. You're pushing the plunger down through thick coffee. This gives you a high resistance, okay? And it's this high resistance that actually allows you to use it to slowly allow the knee to bend to sit down. Using the same analogy of the cafetiere, at this point, the holes for the coffee to pour through are reduced to increase the resistance. Okay, so when we look at the diagram, what we see that the counterweight is held in position, the pendulum is pushed down, holding the stance valve in a closed position. This reduces the orifice for the oil or the hydraulic fluid to pour through, and therefore gives us this counter pressure and resistance. At mid-stance, we see the ground reaction vector and the body line as a natural position. The knee is stable due to the body weight and momentum, and this saves the knee from buckling. Looking inside the knee, what we see is that the knee is stable due to body weight and momentum. However, the hyperextension force is not sufficient to lift the counterweight. Each counterweight requires a pressure to lift it up, and at this point there is insufficient pressure to lift this counterweight. So we're still held in a high resistance even though we have geometric stability for the user. Moving on to late stance, weight is transferred onto the toe. During late stance, the toe off, because the weight has been transferred to the toe, we have a hyperextension moment of the knee. Okay, this switches the stance mode off and allows knee flexion to be initiated immediately prior to toe off from the ground. During this phase though, the body's weight being pressed in front of the knee down through the toe is sufficient to keep the knee straight initially for the patient, allowing them to be stable. And at this point, the unit releases from stance phase and moves to the swing phase, or that low hydraulic motion. Again, when we look inside the diagram, at this point, what we see is the hyperextension moment is trying to pull the piston rods out of the cylinder. This switches up the counterweight and then allows the pendulum to rotate such that it opens the stance valve and switches the unit from the high stance resistance to the low swing resistance. Okay. The advantage of this means that the amputee does not have to use so much energy to get the knee to flex and extend, and it means that they have greater control and use less energy. During swing phase, we have flexion. At this point, we need to adjust the flexion resistance to reduce heel rise. We try to get it to match the sound size and the maximum flexion angle that the patient achieves on their sound limb. Excessive heel rise may make the limb feel heavy, as it means that the leg will spend longer going from fully extend up to its maximum flexion and back to full extension. So try and get it to match as well as possible what you have in the sound limb. Then we have extension. The leg swings forward. There's no longer a pull on the piston rod, so the stance is then touched back on. This supplies a stumble recovery mode or stability in preparation for heel strike. Again, you need to adjust the extension to suit the individual. You want to adjust the extension resistance to slow the leg down and to reduce terminal impact. You want to ensure that the leg is extended in time for heel strike. What we see during extension is that the piston rod is moving out of the cylinder, okay, as the cylinder extends. The knee wants to reach full extension before heel strike. Pressure on the counterweight pushes the counterweight down and switches on the stance phase, ready for the weight to go onto the knee in early stance, as in the earlier slide I just mentioned. Here you can see is adjusting the stance resistance. Okay, yield is adjusted according to the patient's weight and stance resistance requirements. Turn it clockwise to maximize the resistance as an A in the top diagram. Okay, counterwise to decrease. Okay, do not go beyond 6 o'clock and ask the patient to walk. This has the potential to damage the cylinder, depending on your patient's weight and what they do. The mode selection is available via the stirrup. Okay, with the stirrup in the down position, this is its normal function and always allows the full functional benefits of the stance and swing cylinder. The amputee then uses the stirrup to control the user modes. So with the stirrup up, okay, and a hyperextension moment applied, then swing only is chosen. And this is also called the cycling mode by many users and clinicians. At this point, if you have a hyperextension moment in the knee and you pull the stirrup up, the stance support is switched off, so it's constantly held open. Okay, and this is used for cycling and running. Alternatively, if you pull the stirrup up when you have the knee flexed, then it goes into lock mode or flexion lock mode. This locks the knee at the current flexion angle. The limb will always extend, but will not allow you to flex it again. So it can be used for baseball, where you have the bat in your hand, you want to be able to crouch down. You get to your position, switch the lock on, and then you have to hit with the bat and then extend the knee. Constantly, when teaching people to do this, the cycling mode is the easy one. Okay, ask the patient to push the leg behind them, apply pressure down through the toe, and then flick that stirrup up, and then they're in cycling mode. They can cycle off or run, do what they want to do, and then when they're finished, all they have to do is push the stirrup back down, they're back into normal function and ready to walk off. So here we can see a photograph of the stirrup, let's say, with the unit tilted forwards, weight in the toe, pull that up, and then you're in cycling mode. Alternatively, to get the flexion lock to work, what you want to do is flex the knee to whatever position you're wanting to be held in. Okay, pull the stirrup up from this position, and then the knee will no longer allow you to bend. It will, however, allow you to extend the knee till you find the correct position for you. So for golf, etc., what the patient will do is normally get themselves into an angle of knee flexion greater than what they want, so that then they can rise up to the position they have to be in for their swing. It can also be used for planking in the gym. Okay, so have the knee slightly flexed, and then as they extend it, the knee will lock, and this will allow them to perform gym functions. As always, to revert to normal function, flip the stirrup back down at any time. Okay, so once that stirrup is flipped back into its lower position, you are back into normal function mode. The Mercury uses a field replaceable cylinder. Okay, so the cylinder can be taken out by following these instructions. Loosen and remove the stub axles from lower down, as you can see being done here in the workshop. Unscrew the grub screw at the top of the piston rod, the one above the yield adjustment, and then push out the trunnion. That will allow you to take out the cylinder. Take your replacement cylinder, apply a small amount of Loctite, and then reinsert. I recommend using some mineral grease before reinserting the trunnion because it will make it much easier to push through. A small amount of grease on the stub axles and then insert them, initially just hand tight. Okay. Next, flex and extend. So bend and straighten the knee several times. Okay, this centralizes the trunnion and the piston rod. Again, small amount of Loctite on the grub screw and then tighten the grub screw. Finally, torque the stub axles and the lower pivot points to 10 Newton meters. Okay, servicing should only be done by a qualified clinician or technician and should not be tried out by anyone else. To get a service cylinder, you need to request a service exchange cylinder and an ACS number from our ACS department. When you have the replacement cylinder, swap the cylinder as per the video we just showed you, and then return the defective cylinder to us and we will credit you. The advantage of this swapping the cylinder is there's no need for multiple visits. The patient can travel once, be seen, have a new cylinder fitted, and then go about their way. So it makes a major benefit for patients who live a long way from the office or for whatever reason have difficulty getting time away from work to attend the clinic. This reduces the burden on both the clinician and the user. Moving on to how we fit this knee. First of all, it should be pointed out that alignment is critical. Okay, alignment is critical, and the alignment will change depending on which of the two cylinders. I'm going to concentrate mainly on the S&S cylinder, as this is by far the most commonly used cylinder, but there is also the swing cylinder. The stance and swing cylinder, stability is achieved from a high hydraulic yield resistance in the cylinder. The weight line should pass behind the upper front pivot, shown in the diagram, from 5 to 10 millimeters, so that the load of the patient's body weight is being pressed down through the cylinder, and the cylinder is giving you the strength for stability. Alternatively, on a swing-only cylinder, stance stability is achieved through geometric stability and voluntary control. At this point, your weight line should pass 5 millimeters anterior to the front anterior pivot. Alignment is critical. The Mercury releases into stance after a hyperextension moment at the knee. The patient initiates flexion and late stance during weight bearing. It's important to train the patient not to pull back at heel strike to stabilize the knee, because this actually turns the stance mode off by creating a hyperextension moment at contact, which can make the knee unstable. Instead, it's important to work to train the patient to push down through the heel into the ground. This prevents a hyperextension moment of the knee and gives the patient stability. When we look at the alignment required, what we have to do is bisect the socket at the SQ level. You need to fully accommodate the flexion that is actually measurable in your patient, and then typically add about 3 degrees. You want to align down through 5 millimeters posterior to the knee axis. Align the foot in accordance with the manufacturer's recommendations, and check the socket does not contact the cylinder or linkage at any time. Next, stand the user on the rails and ensure the stirrup is down for normal function. Aligning the limb unstable provides a more efficient gait. By having the alignment unstable, it allows for easier for the patient to initiate flexion while weight bearing and late stance, so makes flexing the knee less tiring in swing. Because we have the leg aligned unstable, the high hydraulic stance phase resistance will support the patient, and it's important we check this. So looking at the alignment, when the wearer stands, the knee should be aligned unstable. Ask the patient to stand between the parallel bars. Load the toe and then lift the stirrup. Okay, this will override the stance control and make the knee free, so it will be unstable. Ask the patient to stand tall, with their feet level and their hands resting on the bars for support. On equally loading between the knee and the sound limb, the knee will have a tendency to flex. This indicates an unstable alignment, and this is what is recommended. If this is achievable with your patient, drop the lever and it should now feel stable, and then proceed to yield settings. If, however, when the knee is in the free mode, i.e. the stirrups up, and after you have the hyperextension, and the patient can stand relaxed within the parallel bars and load the prosthesis without the knee moving into flexion, then the alignment is too stable. Okay, that means the load line is passing ahead of the knee center, and this means that the knee cylinder will not function properly, and it will also be more tiring for the amputee. If at this point where the knee in the free mode and the patient stands and you don't see any instances of instability of the knee, what you have to do is slide the socket posteriorly to move the weight line behind the knee center. Keep doing this until the patient can just about feel the knee is going to start to bend when sharing their weight equally through both limbs. Recheck the alignment in the parallel bars as before, okay, until the patient feels the knee is unstable, and then switch the knee back to the stable mode by flipping the stirrup down into its normal function. Next, we want to move on to the dynamic alignment. To release the unit from the stance, high resistance, into swing, the low resistance, there must be a hyperextension moment around the knee, which causes a pull on the hydraulic piston, which switches the unit into swing phase, as I explained earlier. This will happen naturally after mid-stance as the body's weight progresses along the length of the foot. Remember, flexion must be initiated when the limb is loaded in late stance, otherwise stance will re-engage and the patient will advance with the knee in a extended position and can catch the toe, or what we call pecking typically. Confirm that the alignment is okay during swing. The limb is tracking correctly as you would normally. Adjust internal and external rotation of the knee so that we have no whips or gait deviations available. Check the heel rise and adjust the flexion resistance as normal, which I will come to, and then check the extension resistance, again adjust as required. Moving on to the common questions. The Mercury knee is available with two distal connections. The MHPYR has a distal pyramid, and this is the shorter of the two build heights, whereas the 30mm clamp is the longer of the two. It should be noted that the Mercury proximal connectors are ordered separately and do not come as part of the knee. Most commonly used are the rotating pyramid with shift 239017 at the top. This is the one that gives the prosthetist the most alignment opportunities by allowing you free rotation at the knee as well as angulation modes. We also make a non-rotating pyramid with shift 239089. This is the one that I recommend for those people who don't tend to lock tight the knee and follow the instructions. So if you've got someone who just tends to tighten things up with their hand, this is the one that is best to be used. We also have the female pyramid with shift. We have an N36 threaded adapter, a 4-bolt male pyramid, and a sliding male or female 4-bolt. As I mentioned before, the slimlined Mercury knee allows a good cosmetic restoration. The discontinuous must be ordered at the time of ordering. The discontinuous cosmesis or the Mercury comes with a small and medium knee ball, and you cannot convert a standard MH30 or Mercury with pyramid afterwards. So you have to choose at the time of ordering which one you want and then use that. However, one of the most common reasons for using the Mercury high activity is because it has a foam cosmesis that is easy to shape to try and match the sound limb of the user. Another common question is the differences. We make a KX06 and we make the Mercury knee. Both offer variable cadence to the K3, K4 user. They both have user modes, and they both allow a variable yield for leg over leg descent of stairs and for assisted sitting. It should be noted the reason we have two different designs is that the KX06 is designed to be more stable. The KX06 offers greater water resistance and is submergible in clean water. The Mercury, however, has a sleeker design and is a lifestyle change and allows for a better cosmesis. If you have someone who wants to have the limb covered for whatever reason, this leg will give you an easier role in covering the leg. It's much easier to get the cosmesis on. Both units, however, both come with a 36-month warranty. Finally, the summary. The Mercury knee is a robust knee for K3 and K4 users. Okay. It's a single-axis hydraulic swing and stance control, which allows you flexion lock and cycling feature, normal function, but is in a slimline package, allowing you to add a cosmetic cover. We have a durable kneeling pad that will protect the knee for those people who have to work on the ground, and the unit is suitable for outdoor use. For the 150 kilogram option, the Mercury High Activity Knee is commonly used with either the Elite 2, the Elite VT, Elite Blade VT, and the Blade XT. Information of these can be found from our previous webinars and is available on our professionals website. So should you need to look at how to assemble a limb for 150 kilogram patients, please use this knee and refer to the previous webinars. So we have a knee intended for the most active users, those people who are involved in sports, etc., but also a knee that's slim enough that should you have a patient who's going to want the leg covered to get a realistic or a more natural appearance, then this knee can be used. Before we finish, I would like to point out our offerings. Please, for more information on the Mercury knee or any of our products, first point of call should be our website, where you'll be able to find that. Inside our professional area, you will find our clinical compendiums. These are a summary of independently researched scientific papers where we have taken the papers and reduced them to a summary for you, so you don't have to read hundreds of pages. You can just read one page and it will give you what they did in the research, why they did it, and the outcome. We are also keen to provide a growing number of white papers. These white papers are aimed at non-clinicians from the prosthetic field, are suitable for doctors and users, insurance groups, whatever. They are trying to take out some of the science and engineering from it, but to make it easier. So we use less jargon and less technical terms in it so that more people can follow what we're doing, the benefits that we have of these devices, and how we're trying to improve amputees' mobility and overall health. Finally, I'd like to thank you for your time. My name is John Ross. Say I'm a prosthetist. Please feel free to contact me at john.ross@blatchford.co.uk. As I mentioned already, there are more resources for professionals found at blatchford.co.uk/prosthetics/professionals. And we will put future webinars on the website after our short break for our holiday. So please, thank you for your attention, and please connect with us either through the web or through social media. Thank you, everyone. Bye.